Hello, my name is Rod Kowicki. I'm doing a short video on space. See that picture you see behind me? That's Expanse. That's the thing in the universe, the gut of the universe. And it's getting bigger. It's growing. And as it grows, it pushes the stars, actually the galaxies, away. It pushes them away from each other, making more room in the galaxy, in the space for it. It is the core of our universe. It's never been seen before by naked eyes, but this is a picture made by the Webb telescope. It's at the center of the universe, if there is a center. It is the gut of the universe, is what I'm saying. And when the universe was born, this thing was much smaller, and it's been growing ever since, getting larger and larger, expanding the universe as we know it. The further we get away from it, the darker space is. The further we get away from it, the brighter the stars are. What's this thing doing? It's growing. It's so large. It's growing at 43 miles a second. But it's so big that them 43 miles a second are actually 430,000 miles a second. Squared is the energy it puts out. This I have recorded in my new theory that I developed called the quantum physics theory. I just put out a new book. It's called EVG. Expanse vacuum gravity, how vacuum gravity works. Isaac Newton wrote his theory in 1667, and he mentioned what is called universal gravity. Gravity is everywhere, and it's the same. It's 0-point energy. When you go on Earth inside an atmosphere, it seems to be altered by the Earth's core. And so we get a recording of its tension at 9.8 meters a second, which comes out, to your new knowledge, 1 mile a second. It's 1 mile a second. 9.8 meters a second comes out to 1 mile a second. And that's why our planet Earth is considered so perfecto, or perfect. Our measurements are like that. Now you ask me, how do I know that it's accelerating at that much energy is pushing the galaxies and star apart at 43 miles a second, or has a density which is 43,000 miles a second, and an energy the same squared. Because you go back to the beginning, mathematics. It takes twice as much energy to push 1 pound of mass. If you have 1 pound of mass and you want to move it, you can't do it with 1 pound of mass. It would just sit there. They would shake. They would send out vibrations, but that's about it. What would happen? You need 2 pounds of energy to push it. To be, I mean, you could probably use 1.5 pounds, but to be reluctant and even in mathematics, it's 2 pounds of energy. The same way on Earth, it takes 2 pounds of propulsion in a car motor to make a 1 pound car go. But a car is about 3,000 pounds, so it would take 6,000 pounds of energy. And that's the way we calculate things. And when we calculate things, that's how I know, or we know, how much it's the universe, this thing, is expanding to make everything mobile around it. All those stars you see, and actually they're galaxies. Imagine that. All these are actually galaxies. Now, we're on Earth, we look in the sky and we see stars and planets and stuff like that. But you go to this point, and what you see are the galaxies being pushed away from each other as this thing expands, gets bigger, as the universe grows. And that's the quantum physics theory. Thank you for your time, and have a good day. Thank you. Merry Christmas, too.